Let's continue with the next presentation, and we will have now Pengfei Zou, who is the Chief Pre-Sales Engineer from Horizon Energy, and he will talk about Horizon's development trend of size and advancement regarding system compatibility for their 210mm modules.
Hi, Michael.
Hi, the floor is yours. Hey.
Good to see you. Let me share my screen. Can you see it?
Yeah.
Okay. Start it. So the subject of my presentation is development trend and the advancement in compatibility of 210 for utility scale applications. It consists of three parts. Part 1, development trend of size. Part 2, advancement in system compatibility of 210. Part 3, the best solution for utility scale applications under the global low carbon demand. Before beginning, let me briefly introduce my company. Horizon Energy was founded in 1986. We started the PV module business from 2006. Since 2014, we are the Tier 1 manufacturer in Bloomberg list and broke through 10 gigawatt module capacity in 2019. And now we have 19 gigawatt module capacity. Our business involves solar plant development, energy storage, LED, and solar module vertical integration. Our main business is module production. In past years, we have been committed to the optimization of PERC technology and the research on the best solution for utility scale applications. In 2019, we broke the world record of PERC efficiency together with LONGi. In the same year, we firstly released 500 watt using 210mm cells. And in following 2020, we achieved the world's first order for this 500 watt module. Now, as we all know, the cell sizes have undergone a more profound change. In following page, I will show you some interesting data. This is the forecast wafer size released by PV4Link in the first half of this year. By 2025, they think there will be 70% of global market belonging to 210mm wafer or larger wafers. And they think 158 cells will be eliminated in this year. As a PV manufacturer, actually, we think this prediction is becoming reality for us. Here is the proportion of shipments rising in the first 3 quarters in 2021. Yellow part is 210mm module. Brown is 166. Blue is 158. From Q1 to Q3, the proportion shipments of 210 module have been increased by 3.5 times. And the 158 have been reduced by 4 times. The 166 module changed little here. We will still keep a part of module capacity, module capability for 166 in future, but 210mm size is definitely the mainstream for us. This year, we have 13.5 gigawatt for cell production and 19 gigawatt for module production. The proportion of 210 cell is 63%, and proportion of 210 module is 53%. Next year, when our new factories are finished, there will be more 10 gigawatt module, 210 module capability. By then, the proportion of our total module will account for at least 80%. Now, all of our mainstream module types are based on 210mm size. The cell is big. Module designing is very flexible. We use half-cut cells or triple-cut cells, 5 strings or 6 strings, P-type or N-type cells. to adjust the module's shape, size, and the power to suit different applications. Here's a 400 watt and a 500 watt module for residential and commercial rooftop markets. Another 4 types are for large scale applications. So for Ryzen, we will only need 1 cell size in future, which is enough to deal with almost all the application scenarios. In the past, people had some doubts about 210mm size. And with the passage of time, all of these doubts were resolved. In the second part, I will talk about the advancement in system compatibility of 210. Every change will bring challenges, but the times will not stop for challenges. In past few years, the cell sizes have been rapidly increased from 156 to 182 and 210. Among all the changes, the 210mm is the most revolutionary. So it also faces the most controversy. Larger wafer size means higher power, but also bring higher current. And then it may cause some concerns about heat generation, inverters compatibility, installation compatibility, and packaging feasibility. In following page, I will show you how these issues are resolved. In the very beginning, people thought the larger current of 17 ampere of 210 cells will bring more heat generation and may accelerate the material aging. And they think the 210 module's reliability is uncertain. But they forgot 2 points when they made such speculate. First is that for half cell module, the current will be divided on the 2 parallel circuits. So the internal operation current of 210 module is only 8.6 ampere. That is lower than the current of conventional full cell module, which was once the mainstream module types in the past. And the second, the higher current will be more evenly distributed on a larger wafer surface. Heat is generated and is quickly dissipated. No heat accumulation, then the temperature of cells will not be increased. We will use 12 bus bar on this 210mm wafer, and the current on each wafer is only 0.7 ampere. And we can further calculate the current density on every square centimeter. The 210 module is 39.22 milliampere, and 182 module is 39.55 milliampere. So the current characteristics of 210 module and 182 module is very similar. Our testing also tells the same. According to the law of conservation of energy, the loss of the electricity is equal to the heat generated. So we gradually increase shading area on different modules and estimate the heat generation performance by measuring the power loss. And we found that the heat performance of 210 modules is very, very close to other similar module types. In the past, the MPPT current of most inverters is 26 ampere or 30 ampere, suitable for modules with current lower than 15 ampere. And our 210 modules current is 17 ampere. So the problem is just to increase the MPPT current. This is not a difficult thing. Many mainstream inverter manufacturers have released their new products, especially for 210 module. Here I listed Huawei, Silent Electric, Sungrow, Ganon. They are the inverter manufacturers cooperate most closely to us. And as I know, there are more than 14 inverter manufacturers having solutions for higher current of 210, covering more than 80% of the inverter market. Another concern is about the mechanical load capacity of this super large module, especially on tracking system. Most of the tracker are still using 400 mounting position. That puts higher requirements for the material strength of our 2-ton module. In this regard, we have in-depth cooperation with many tracker manufacturers. We made lots of tests and released approved letter together with all the tracker manufacturers are listed here. And in future, we will further apply our high strength alloy steel for the frame of 2-ton module to further strengthen the load capacity. In recent years, so all the compatibility issues are solved. The advantages of 2-ton module on utility applications is unparalleled. And as we know, in recent years, more and more countries have announced their carbon reduction goals and strategies. Together with other renewable energy sources, the photovoltaic industry is becoming more and more popular. More and more PV factories and large-scale solar plants will be built in future. As PV manufacturer, we not only produce clean energy sources, we think we can do much more. Providing modules with higher power and higher efficiency is only one of our goals. And the global low carbon trend, it's increasingly important to try our best to integrate resources, improve the utilization of raw materials, and reduce carbon emissions from module designing, bill of materials, and production process, from silicon road to wafers, cells, modules, and solar plants. And 210mm size is definitely an excellent platform to achieve this goal. And based on this platform, we will further apply high efficiency cell technology and new frame materials to contribute more strength to the zero carbon emission goal. So in third part, I will talk about the best solution for utility scale applications and the global low carbon demand. When size is increased, the effective part or output power of final products will also be increased, and that happens in every section of the PV industry chain. In other words, when we choose 210mm size, we can get more output under the same amount of time. And the investment per gigawatt for production lines will also be reduced compared to the 182mm size. The production line of 210 can be reduced by 20%. And for modules, larger cell size will increase the utilization of module surface, the increased utilization of materials such as glass, backsheet, and the EVA. And when size is increased, the area will always grow faster than the parameter. And for PV cells, area means power, parameter means cost of materials such as frame. So the used material per watt can be reduced when we choose larger size of cells. In PV system, when single module power is increased, the total number of modules needed in a system will be fewer. Using 210mm cell, our module can reach a much higher power output with fewer number of cells. Then we can get much lower open circuit voltage. Then we can put more modules together in a series circuit. The total number of module strings needed in a project will be fewer. That's how the 210mm modules reduce the BOS cost of the PV system. Here in the list compared to conventional modules, 210 module with 600 power can reduce brackets by 10.8%, reduce pipe foundations by 16.3%, and reduce cables by 20.7%. In addition to size and power, we will use new frame material. We call it high strength alloy steel, which is completely different to the anodized aluminum alloy. In 2020, Chinese electrolytic aluminum output totaled 37 million tons. Electric energy consumption is about 500 billion kilowatt hours. Carbon emission is 415 million tons, about 5% of the total carbon dioxide emission of the whole society. And this year, China implemented the most stringent electricity curtailment policy. We call it double reduction and power rationing. But by the end of Q3 of this year, the production reduction of electrolytic aluminum in China is more than 3 million tons. In addition, it may delay the production capacity to be put into operation of more than 2 million tons. At the same time, there will be more and more electrolytic aluminum demand from the photovoltaic industry, new energy vehicle, and many other industries in future. Aluminum prices have continued to rise from 2020 and reached their peak in 15 years, in recent 15 years at the end of the third quarter of this year. And Chinese government aims to have carbon dioxide emissions peak before 2030 and achieve carbon neutrality before 2060. So we think this situation may continue for a long term. This is a big background for why we want to try new frame materials. And compared with the aluminum industry, the energy consumption of steel material can be reduced by 3 times, and the carbon emission can be reduced by 6.2 times. So we think the steel frame is a more environment-friendly material. And of course, we can not only consider energy consumption and the environment. Material reliability is also it's the most important point for PV module. And it's easy to understand that steel has higher strength than aluminum. Here I list some performance data. The strength value of steel material is up to 1000 megapascal, and aluminum is 210 megapascal. And steel also has higher elastic modulus than aluminum alloy. So with higher strength and the higher elastic modulus, the high strength alloy steel frame will have smaller deformation and heavy load. And the probability of cell cracking of modules will also be smaller. And the thermal expansion coefficient, this coefficient of steel is closer to glass than aluminum. This will reduce the risk of the self-explosion caused by thermal expansion and contraction of modules. And the tear resistance of high-strength alloy is also better than aluminum. It can reduce risk of mounting holes tearing and high wind load. To achieve 25 or 30 years warranty period, a good anti-corrosion performance is necessary. We use coating of zinc, magnesium, aluminum on the steel frame surface first. Then we will cover the outer layer with a special protective film. Similar to the original aluminum oxide coating, the new coating will also have an ability to repair itself. In some alkaline environments, the ZAM coating is even better. And for cell technology, we will combine our Newton technology with 210mm wafers. The Newton is based on tungsten oxide passivating contacts combined with a part of HJT technology. Its cost will not be as expensive as HJT, and it has a higher efficiency than PERC cell. The power of 210 modules with Newton technology is up to 700 watts. And the warranty of this new cell is also better. For our Newton servers, the warranty performance in the first year will be no more than 1%, and in the following years, annual degradation will not be higher than 0.45%. In 2019, we released the world's first 500-watt high-power module. Then modules industry entered the 500 era. This year, 2021, we achieved mass production of 600-watt module. And next year, we'll come into 700 watt. When sales increased from 158 to 166 to 210, the power is increased with size increasing. The BOS and LCOE is reduced because huge power increase on single module. This time, for Newton series products, we will further increase the module size from 120 half cells to 132 half cells, and combine with the Newton technology to bring a huge power increase, then further reduce the level of the cost of energy. So, 210mm wafer and high efficiency cell technology of Newton and high strength alloy steel are Ryzen's solution for utility scale applications and the global low carbon demand. That's all of my presentation. Thank you for your time.
Thanks, Peng. This was a very concise conclusion. A nice final slide. Just a few questions. Maybe let's start from the end. You talked about the new cell technology you are looking at, which will be a combination of TOPCon heterojunction. So far, you have been mostly focusing on HJT. So what does that mean that you now go one step beyond? Sounds at least at first sight as if you were adding complexity rather than taking it away. So what does it mean for your heterojunction plans that you originally had?
Yeah. So the reason why we choose Newton technology is not to say we will give up the HJT road. The reason is only because Newton is easier to control the cost in mass production. You know, the HJT requires a low temperature processing, and so its equipment and production lines cannot be compatible with PERC technology. And but HJT has its own advantages, such as a higher potential efficiency, much better temperature coefficient, and better bifacial factors, and lower LID and PID performance. So, and we think the Newton technology and the HJT technology are not contradictory. Newton currently is mainly for large-scale mass production, and HJT is for some high-end users for rooftop market. So we will keep both of them.
Okay. In terms of if you would just go the HJT path and then compare it again to Newton, so what's the additional gain you get if you go this one step further? So maybe traditional to HJT and HJT to Newton.
Compared with HJT, the Newton technology will not have such higher cost. But its efficiency is up to 24% in mass production. So it's this efficiency is much higher than PERC technology, but not as higher as HJT.
And then first products we can expect for 2022.
Yeah, 2022.
Okay.
Maybe Q1.
Okay, wow, cool. Maybe just quickly on the steel frame cost reduction again. So I think how much you save on this? I think it's important these days when prices for materials are only going higher.
Currently, I didn't get the cost information actually. Since, as you know, what we are focusing on is a higher strength and advantage on the carbon emission. And maybe the steel material is cheaper than aluminum alloy. But what we are talking about is a PV frame, not raw material. Further processing and coating will be needed. So, this steel frame is still in a preliminary stage. More and more R&D investment will be needed in future. So it's hard to say its cost now. But personally, I think it can be expected to get a lower cost in future.
Okay, super. Yeah. Thanks, Pan. Okay, that's great. We continue now. I think if you have also time, please address some of the questions you will see in the chat in written form. So we continue now with the next presentation. I think that's